streaming data science or streaming analytics combined with edge analytics and fog analytics. From analytics perspective, this poses a challenge. Earlier, whatever analytics were done or regression models which were done on classical historical data now needs to be converted to streaming and real-time necessity. So in fact, you can take a simple mapping. If you want to do an unsupervised learning algorithm called k-means, it cannot work as is on a streaming of data. You have to do what is known as streaming k-means. So there will be upgradations of all the knowledge, all the algorithms which have currently been working on in data science, both regression, machine learning, unsupervised, supervised, time series models, now will have to be refactored for high speed, high throughput, high volume, high velocity streams coming from IoT. So I think it's a synergetic combination. It's going to provide a life to data science, and data science is going to help IoT evolve to the next level. So in that sense, I feel it's a symbiotic relationship.
Oh, I was trying to turn it off. Okay. So I think, thank you, Srini, for that.
I think if you guys can just introduce
Yes, that's exactly what I'm going to do. I'll introduce myself briefly, and then I'll also tell you why I think the data scientist or the big data is very important in what I do. So as they introduced, I drive sales for public sector for Intel in Asia Pacific, Japan. And my day job is basically, I pick up what we manufacture as Intel, right? Which is primarily the storage, compute, gateways, sensors. I take them to the customers and say, hey, how can I actually use these to help solve your problems? And I think traditionally, salespeople are used to probably selling products. We go in and sell a product. But the things have changed. Now the customers are asking for business outcomes. They're like, I have this problem, and how can you as Intel help me solve the problem? So we actually delve into the problem. We say, okay, what are the problems? Then how can technology probably help solve the problem? But the thing is, I think probably until 5 years ago or 6 years ago, it was all based on empirical evidence, which is, someone has 25 years of experience or 30 years of experience, and they would say, probably you can solve this problem this way, and here is how you achieve the business outcome. But the things are changing. Now the customer wants empirical evidence, right? Which is, can you support this with data? Is it real-time data? It's, can you actually support what your hypothesis is? Because I'd spent some time in management consulting as well before taking up this role. And it's all about, I have a hypothesis and I'll solve that problem. I think this is how we're going to solve. But the thing is, now data is becoming an integral part of that problem solving. And that's why my day job is to sell what Intel produces, but my night job is to actually do a quick research on what's happening in big data, what's happening in cloud, right? I keep myself up to date. And I think that data science and justifying what we think is the solution with that data will actually add to my credibility. And I think that's how we actually grow in an organization or with our customers. That's why data science, big data, is becoming an integral part of the industry itself. It's not just limited to one vertical, across the verticals. So, thank you.
Thanks, Kavitha. Hi, my name is Raghav. I'm part of the data science team at AIG. I have around 14 years of experience, which has primarily been in the analytics space, right? So I think Dr. Srinivas touched on a lot of very critical points in terms of why data being generated from IoT is coming at such a fast pace, right? And it's very important for us to analyze the data at the pace at which it's coming. I think I would like to bring out a couple of points, as to why IoT is here to stay. I think the question is not whether I don't think there are any doubts on whether or not IoT is the next frontier. I think it is the next frontier, primarily because I think when you look at the size of the sensors itself, I think it's coming down drastically. The mobile phones that we carry on a day-to-day basis has anywhere between 5 to 9 sensors, right? So if you understand, I mean, if you look at gravity, it has everything else that it can sense, movement, motion, everything. The other aspect is the cost of the sensor has actually come down drastically, right? So if you look at what's happening in the last 3 to 4 years, I think it was possibly close to $2 to $2.50. I think right now the cost of a sensor is as cheap as maybe half a dollar or maybe 40 cents, right? So I think these are the two primary drivers as to why the adoption of IoT or sensors is increasing, right, on a day-to-day basis. The other aspect is, there are a lot of companies which have already started monetizing IoT as, and start making money off it, right? So if you think about it, there are possibly 4 levels of monetization which are possible today, right? So the first level is the hardware level, where you have devices like either a Fitbit or an LED bulb, right, which you can possibly control through your app, and then, the Fitbit gives you information on how many steps you have taken and things like that. That's at the hardware level. The next level could possibly be at a service level, where you could have all these connected cars, right? And they display information on the dashboard depending on maybe which part of town are you in, right? Or maybe they can provide you upgrades on the different aspects of the car performance. So that's one. So this is where I think most of the monetization is typically happening, at least at these 2 levels, right? So at the next level, when the complexity increases, when you have all these self-driving cars, right? So I think that's where the challenge really starts. Because then you need to partner with third-party services like, maybe Google Maps, because you want to understand the terrain, right? And if you have self-driving cars, right, how effectively can a car perform, right, in conditions which are alien to it, right? When the road is really slippery, or at night conditions, maybe, as may the case may be, right? And last but not the least, I think the whole ecosystem of smart homes is one big area which is coming up. I think Tesla is taking the lead by, bringing in, battery storages which can store solar power for a longer period of time. I think they call it the power hub or something like that, right? So, and then they can possibly, you can draw power from them when, the peak hour rates get charged, depending on which area you live in, right? So I think, but for that, I think the problem is that you need to really be connected with the third-party services. So that is one area which possibly will take some more time from a monetization perspective. So 2 points, and the third point which I want to quickly talk about is from the core analytics perspective. I think from a data science perspective, we are all interested in what kind of analytics can we really do, right? So I think there, anomaly detection becomes a very big problem a very big issue for us, right? So while you have data streaming on a regular basis, how do you figure out, what is going wrong, or can I predict something in advance if something is going to go wrong? So I think there are a huge number of applications there. I mean, you could talk about technology, you could talk about servers. You could say what is the probability of a server outage happening, given that so many connections have been made or so many requests have been made on the server. I think that list is endless. And the other challenge, from a data science perspective is, I think, and Dr. Srinivas touched on it, is there are sensors which will give you information at different time frequencies, right? So for example, temperature is something which will maybe come to you, every second, for example, right? But then think about it, in a commercial insurance space, if I'm trying to, insure a cargo ship going from place A to place B, right? And I want to understand how risky is the entire travel, right? I can have a number of sensors embedded inside the container itself, right? And I can see if the temperature outside is fluctuating a lot, which might do damage to the goods, especially in case if they're perishable, right? And the second aspect is, even inside the container, I could possibly understand if, if it's going through a cargo ship, if the vibration is very high, and hence, maybe there's a potential damage. Now, the challenge here is the frequency at which the data is coming in from these sensors is not the same, right? So when you're trying to model all this information, I mean, creation of your spatial temporal data becomes a very big challenge. And for me, I think, how do you create, very generic space-time features, try to make sense of all this information coming in, and last but not the least, make a sense of it at the pace at which it's coming in is possibly going to be the biggest challenge as far as data science is concerned. I think a lot of companies have already made a lot of stride in that space, and that's I think there's a lot of scope as well going forward. Yeah, so.
Thanks, Raghav. So very briefly, I have about 18 years of experience across B2B and B2C industries, petrochemical consulting, airlines, technology, and financial services. Thinking about is IoT next frontier for data scientists? I would like to answer that question from a business impact perspective. What's the business impact that potentially IoT can drive on industries, on companies? And I was reading some research reports that say that in next 5 to 10 years, when IoT matures, it will have anything between 6 to 8 to 10 trillion dollar of positive impact on global economy. which is not small, which is about 8 to 10% of overall global economy, global GDP. So when you have that kind of impact, the answer to the question that is IoT the next frontier, it's obvious, yes, of course it is. The next question becomes, okay, so where all is the profit pool? Where all is the landscape where IoT is highly applicable? And really, this is primarily a B2B play where you have industrial automation, factory automation, preventive maintenance, a number of use cases that are going to have huge impact actually are going to be on B2B side. On the B2C side, there will be certainly opportunities, but in terms of scale and size and impact, they're going to be slightly smaller. And I personally believe that ability to automate your ability to bring IoT in your, say, aircraft maintenance, in your factory operations, even if you improve those productivity and efficiency there by a percentage point, the impact on companies' operations is going to be huge. So a lot of work is happening in the industrial space on leveraging IoT. When it comes to the other area where there's lots of opportunity and clearly application is the healthcare, preventive healthcare, monitoring chronic cases of patients and being able to act before an event happens is where IoT will play a critical role. Home automation, security, all of those are potential application areas, and we can go on and on. So when the use of IoT is going to be so widespread, what we need to really enable, and some of my fellow panelists talked about it, is the amount, the volume, and velocity of data is much more than what our storage systems, our processing systems can handle today. How do you get past that? And the other thing is it's a different kind of data. It's not the data that you're used to, unstructured data or the traditional databases. So signal processing data, when it comes in, how do you utilize that for making decisions? I think that's the biggest challenge. The challenge is around ingesting that data and then being able to process that. And even before you do, there's going to be huge investment needed in terms of building the pipeline and connectivity. So there's no point in having a smart device on yourself if it doesn't send signal to, let's say, either a hospital or your doctor or whatever it is, where you can have some insights from that and then action can be taken. So somebody has to create that pipe and connectivity where this IoT data will be looked at and analyzed and certain actions has to be taken. So that's a big investment. And one of the challenges there could be that the CapEx is huge. The companies will need to make upfront investment in creating that kind of pipe. And the investments will, the return on that investment will probably take some time to come because you don't see the ROI immediately. So committed companies with medium to long-term vision of leveraging benefits from IoT are going to be the ones that will benefit the most. So, I think as we progress along the discussions, we probably will touch on what specific skill sets and what specific actions and competencies will be needed for a data scientist to be a successful IoT scientist. Yep.
Thank you, Sanjay. Yeah, Raghav, you wanted to add something?
So just to add to what Sanjay said here, I think IoT is one more area which is also already causing a lot of disruption, right? So take a look at insurance as an industry, right? So people are already thinking about what's going to happen when the percentage of fleet with unmanned cars is going to go up. Right now, what we are looking at is insurance as an auto industry where accidents happens and claims come in, right? What happens when a lot of unmanned vehicles start coming in, right? Whether it be on the roads or when you have drones flying all the place, right? So in fact, AIG is one of the very few companies that has started off with drone insurance. And I think that is one area which not only has applications with respect from an insurance perspective, but also, especially in the commercial area, right? So if you want to go ahead and do assessment of places where there's maximum damage, drones is already being used. So I see IoT is also a big player in doing disruption across various industries.
In fact, I wanted to bring about a different phenomena that's happening in the industry of insurance, which is the micro insurance, which is, you're used to paying that premium monthly, right? That's the typical insurance plan. But today, most of the US insurance companies, from Allstate to everyone, are using the concept of pay by the second. Depending on a sensor established on the car and depending upon the braking pattern of the driver, your insurance is going to change every second. Can you believe that? That's what is the future, how IoT is going to disrupt. And for that, you know what they need to do? They need to take the raw data from the device, which is the braking speed, convert that to a very high-level metric, which is the behavioral aspect of the driver. Is he a safe driver? So imagine if we didn't have IoT plus data analytics, would you be able to answer from a raw metric like the braking speed and the force with which somebody is braking to his driving pattern? And see how it's disrupting. It is disrupting from $20 a month to some cents per minute. And it depends on, maybe while going from this part to that part, it's a safer journey, but when you're returning, it's evening, so your same path while returning may be costlier because of the profile of the road, profile of the traffic, etc. So think about the disruption of that kind.
Thank you. So before the panel started, somebody mentioned to me, why are most of the speakers in most of these videos women, right? And somebody else answered, probably because they're good communicators. And I was wondering to myself, I wish there was an IoT device which could actually capture all the voices that happen in conferences and then distinguish which are women and men, and then figure out, do analytics on that and figure out what's the ratio and what were the most effective ones, and you know, answer these questions. Yeah? And then I thought to myself, oh my God, that's just an answer for a joke room, not really for a real business. Is that not? So then the next obvious question came to my mind was, so then is IoT for real? As in, is it here to stay? Are businesses going to adopt it the way we are envisaging it to be? And looks like from what our distinguished panelists are saying, they are in agreement that yes, IoT is indeed here to stay. It's not just for hobbyists, it's not a hype, it is a business paradigm. So Kavitha, you are from sales. From sales perspective, would you like to share, when you go out and try to sell, say, Intel IoT chips, the hardware, are there real business takers? Yeah? So from business, in that sense, like where is the real business impact?
Sure. I think I probably touched upon it in the previous iteration, right? That, yeah, it's all about business impact, business outcome. But if you're talking about, let me just like change the gear about, like what's the role of a data scientist in this entire process? So the way we go about doing it is, Intel is known to be a hardware supplier, right? Like traditionally. But the thing is, Intel has been acquiring some software assets like Cloudera, Trusted Analytics Platform, and then, Wind River, a few things basically to create that IoT stack. When we say IoT stack, you have the hardware, and then hardware can only probably provide so much intelligence, and sometimes you have to create context. Like you take a gateway, as Dr. Srini mentioned. Gateway can be used in a healthcare vertical, it can be used in a transportation vertical, or it can be used in a different vertical. That intelligence will come in from the next layer, because hardware to large extent, I know, of course, for those of you that are engineering inclined, Intel acquired another company called Altera, which can bring in a little more context sensitivity into the hardware. But the thing is, we rely a lot on application developers and independent software vendors to bring in that additional intelligence, right? But throughout this process, it's important for us to understand the context in which the hardware is playing. Let me give you an example. If you have a camera at a traffic junction, that camera can be used for security. It can be used for traffic management. It can be used maybe for crowd control. It can be used sometimes maybe for environmental monitoring too. But the thing is, unless I really know what the data is and the context in which it's operating, it's hard for me to use the data and create an architecture on top of it. So we believe that when we marry this hardware, which Intel is known for, and other software assets, with applications and with the software, it's very important to have a data scientist in the room, because that